Hi guys, today we're going to cover section 4.1, solving systems of equation by graphing. So first thing we need to know is what is a system of linear equations. So by the definition we give in class, a system of equations is basically means a collection of equations. Okay, a collection of equations. Now we're going to talk about the type of systems, and by the way, in this class we'll be dealing solely with the system of linear equations. So which means all the equations will be either in the form of y equal mx plus b, ax plus by equal to c, or y minus y1 equal m times x minus x1. So if you don't remember what these are, it's better if you start brushing up. Okay. Now, the way we define the type of system is by how many intersections the lines have. So which means when you draw two lines, you could have one intersection, no intersection. So let me write this down: one intersection, no intersection, or zero intersection, or last one, overlap. Now, if you overlap, that means you have infinitely many intersections. Okay, now, so here are your three types. The one with the intersection is called the consistent independent. The overlap is called, let me use a different color on this one. The overlap one is called consistent dependent. And the last one, the one that's parallel line, is called the inconsistent. Okay, so the way I always think about it is, if consistent means the lines touch, that means inconsistent means the lines don't touch. So therefore, inconsistent has to be parallel lines. All right. Okay, and the last part, what is a solution to a system? So the way we define the solution to a system is the points where the two lines share. Okay, so that basically means when you have a solution to a system, this means the point of intersection. Okay, so the point of intersection is the solution to a system. All right, so let's go ahead and let's do some graphing. So now we have the equation, we have the system with the equation y equal -1/4x plus 3, and the other equation is y equal 1/2 times x. So let's go ahead and draw our line first. That means get my grid going. So from here, right, make sure you know how to graph. So I'm going to graph the first equation. My y-intercept is 0, 3. And my slope is -1/4 or 1/-4. Just totally your pick. I'm going to use -1/4. 1 and 4 to the right. Down 1, 4 to the right. Now, if you use 1/-4, that means you're going up 1, 4 to the left. Up 1, 4 to the left. But it doesn't matter which way you go. When you draw a straight line, which Alex will help you with that, all the points should line up. Okay. All right, let's go ahead and let's go ahead and use the next equation. I got y equal 1/2x. Now this means the y-intercept is 0. So I gotta go 1 up, 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right. And looks like they do intersect at the point 4, 2. So the solution is x equal to 4, y equal to 2. Okay. All right. So yeah, so definitely you need to know how to graph your linear lines, and then all we gotta do is find the intersection. So, all right, let's go and move on to the next problem. Okay. Let me erase some of these. Okay. So here we go. Let me draw my line again. Now this time we got y equal to x plus 2. So I'm going to graph that first. Y-intercepts at 2, so it's at 0, 2. Slope is 2 over 1. So that means up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right. Or you can go down 2, 1 to the left. Down 2, 1 to the left. Doesn't matter which way you go. All right, second equation, you have the slope that is negative 3 over 1 or 3 over negative 1. But we know the y-intercept is at 7. So this means I gotta go 1, 2, 3, 4, 5, 6, 7. So 7's right here. And then I'm gonna go to the right, just because otherwise I'm gonna run out of space. So I'm gonna go down 3, 1 to the right. Down 3, 1 to the right. Down 3, 1 to the right. And check this out. It just come out fairly nice. So it looks like the intersection right here is the point 1, 4. So x equal to 1, y equal to 4. Okay. All right, so hopefully this helps. Okay, let's move on to the next problem. Alrighty. All right, so now for this problem, notice that they gave us the equation in different formats. So I'm gonna go ahead and solve. Okay, I'm gonna go ahead and solve the equation sum into y equal mx plus b. So negative x plus 3y equal negative 6. This means I should add x to both sides. I get 3y equal x minus 6. Then divide by 3 on both sides. This means y equal 1 over 3x minus 6 over 3, or basically 6 over 3 basically means it's 2. Okay. So I'm going to graph this first. I have 2 as my y-intercept. Slope is 1 over 3. That means 1 up, 3 to the right. 1 up, 3 to the right. Or 1 down, 3 to the left. Okay. So connect the dots. All right, now let's deal with the second equation. 6y equal to x plus 6. This means I got to divide everything by 6. So I got y equal 2x over 6 plus 6 over 6, which is 1/3 x plus 1. And this shows that my y-intercept is at 1, but my slope is the same as the previous equation, which means I gotta go 1 up, 3 to the right, 1 up, 3 to the right, and you can tell that they are parallel. Okay, they're parallel. So which means no solution. All right, last one. So what we have here is, I'm going to draw my axes. So again, I'm going to set the y equals in the y equal mx plus b. So first equation, x plus 4y equal to 8 minus x on both sides. I have 4y minus x equal, going too fast, sorry. I got 4y equal negative x plus 8, which means divide by 4 on both sides. I get y equal negative 1 over 4x plus 2. Which happened to be the same as the second equation. So this means if I graph it, I'm going to have y-intercept at 2, but my slope is going to be negative 1 over 4. So that's down 1, 4 to the right, down 1, 4 to the right, or up 1, 4 to the left. Okay. So this shows that these lines overlap. That means you have infinite many number solutions. Okay. All right, and this is it. So as long as you know how to graph the lines, you should be okay. You got any questions, please let me know. I will talk to you guys later.